Hello and welcome to Dunslet, a channel for intelligent and curious people like you who are searching for human sexuality in the age of artificial intelligence. And in this channel, we usually try to find the best possible answer to a question. And today's question is how center of gravity and current balance make it happen while doing sexual activities with your robot partner. Now, humanoid robots use a variety of sensors, and I talked about sensors earlier in a lot of videos to estimate their center of gravity and current balance. Basically, it's a responsibility of sensors, of course, but there are some more features that we need to know about this whole process. One is gyroscope, the second is accelerometer, uh, third is force sensor, and the fourth and the final one is joint encoders, which is new, of course, because I talked about gyroscope, accelerometers, force sensors in my earlier videos. A lot of discussions were there. If you are interested, you can find them in my previous videos. But I have not talked about yet about joint encoders. Now, joint encoders basically measure the angle of the robot's joints. you know Between two fingers joints there are angles, right? So depending on the on that angle, the trajectory is calculated. So how these things happen, I mean, this center of gravity and current balance, how these things happen, how these things coordinate together to make it happen while uh, you are having any kind of physically intimate act with your robot partner. Now I try to break them in a few steps, okay, so that you can understand the whole process. Number one is the robot's computer uses this sensor data to create a model of the robot's dynamics, which includes its center of gravity and balance. This model is used to predict how the robot will move in response to different actions, such as stepping forward, or turning, or jumping, or riding, or walking, or moving, any kind of things, right? After that, the robot computer also uses the model to calculate a control signal for each of the robot's actuators. These control signals are used to drive the robot's joints. Basically, in any kind of physical intimate act, the role of joints are very, very important, which causes the robot to move because these joints actually cause a robot to move. The robot's computer continuously monitors the robot's sensor data and updates the model of the robot's dynamics. This allows the robot to adapt to change in its environment, such as uneven terrain. It could be uneven terrain, it could be your bed, or any kind of unexpected disturbances. Okay, to move these limbs, its limbs, keeping balance, a humanoid robot must carefully coordinate the movement of its joints, and this coordination is a very complex task, as the robot must ensure that its center of gravity remains within its support polygon at all times. Otherwise, it will fail. So it's a very important center of gravity is a very important concept in keeping our balance, not only for human and robot, but for humans, for every animals in this world. So the robot's computer uses the model of the robot's dynamics to calculate a trajectory for each of the robot's limbs. This trajectory again is designed to ensure that the robot's center of gravity remains within the support polygon and that the robot moves in the desired direction. That means while having any kind of physical intimate act, the direction is important also. So the desired direction, in which direction it will move, its legs or hips or any kind of necessary parts. So ultimately, robot's computer then sends control signals to the robot's actuators, that means the motors, which cause the robot's joints to move along the desired trajectories. I hope it ultimately, and basically, the robot's computer continuously monitors the robot sensor data and updates the model of the robot's dynamics. It is an ongoing process. Okay, so this allows the robot to make adjustments to its movements in real time to maintain balance. So this is the whole process. I just told you in a few steps how it happens. Thanks for watching. I hope it gives you more insights about your robot partner. I hope so. So thanks for watching. Thanks for your time. Keep watching Wooden Sled. Keep supporting Wooden Sled. If you have not subscribed yet, please subscribe. It means a lot to me. And if you have already subscribed, thanks. Many, many thanks.